Hi Keith, this is Diego Pedreros. I'm recording this to better explain what the tool does and so that the students could really get the idea. So we work in this case is Ethiopia, but we work with a data set of rainfall that goes from 1981 to 2018 and all the way to the present. And what we do is, in this case, we have selected all these different polygons. So we do monitoring for each of those areas in the region. So what we do is we extract the value for every decadal total, this 10 days totals, and we extract the time series for each of those polygons using a tool that we have created. Then it looks like this. This is for polygon 1, polygon 2, and so forth, all the way to polygon 27. And each of these is the value for that 10 days total. This is uh, 2017 decade 25th. Those are There are 36 decades on or decades on in a year. So this is decade 25th, 26th, and so forth. So we have all the way from 1981, decade 1, all the way to 2018, decade 10. So that's the entire time series for that polygon 1. So that's the idea, is that we're going to analyze each of those polygons. So the tool that I created is this. I call it the SMPG, is the Seasonal Monitoring and Probability Generator tool. So what the tool does, it takes this huge line for every one of those polygons, and when we run the tool, it runs a macro in the background, and the macro gives us, right now is running polygon number 10 of 27, number 12. So it's taking each of these lines, running the macro, and we'll see what the so it's running now is running number 27, and it's done. So it created a tab for each of the polygons, and it gives the name, whatever name we had in here, it gives it to the tab. So let's take a look at polygon number 1. So now it finished running. So let's take a look at polygon number 1. So it is a huge table. It has all these different formulas, but all those formulas are to create these three things. The first thing, it takes the time series and puts it in format year by year. Then it plots the average rainfall for each of these decades in a year. From January, first decade, every month has 3 decades, and and then 36 in the entire year. So we calculate the average for decade 1, decade 2, and this is the average right here, and that is plotted in this red line. So that red line is the average rainfall for that particular polygon during the year from January to December. Then it plots the last year. So this is how the rainfall for this current year all the way to the first 10 days of April have behaved so far. So right away we see that the season is below normal, right? So then that's the first plot that it shows. Then it comes here and it shows the, the accumulation for each season. So each of these years, each of these lines is a season or a year going from the first decade of February to the last decade of May. So we are analyzing from February to May. We are monitoring the rainfall for that particular polygon. The red line is the average rainfall for the average rainfall for that particular polygon, and this line right here is the current year. Now I have to update that current year from here, because it doesn't do it automatically. That's one of the little problems that the tool has. So this is now updated. So what we are seeing is that the cumulative rainfall for this season is way below normal. So that is a very important, just visualizing this is very important for any decision makers. So they could provide more seeds or decide. There are other tools that we use that determine how bad this situation is affecting the crops and so forth. So then once we see this one, the second tool that we have is, or the second plot is showing us the rainfall up to the point where we are right now, the first decade of April. Then from here on, it continues, every year continues as it happened. So this is an ensemble. So every year after decade first, after the first decade of April, every year continues with the rainfall as it happened. So to this point is the same, but from here on it continues going on as it happened at that specific year. So this starts showing some probabilities on of the different possible outcomes. So we start looking at what's the probability for the rainfall this at the end of the season be below normal or above normal. So we are seeing in this case that this right here is the more probable outcome, this dotted line. So that means that we are in pretty bad shape, because it looks like the season is going to be way below normal. So then this is a way to do some forecast and based on that plot. But then we come here and we have a whole statistical analysis that for the seasons based on all the different years. Before I continue with that statistical, and I have to show you this. This is the analog years definition. So what we do is I don't want to go into big detail on this, but we determine what are the years that are closest to this year. We do some ranking by calculating the differences between this year and all the previous years. Then when the rank is high, like 37, 36, all these high ranks, that means that the year is very far away from the current year. But those low values like 3, that means that 2008 was very close to 2017. So 2008 should be something around here. Then based on those ranks, we could turn on or off. For example, if I want only the very close years, I could start turning off all the very high values. Then as you see, as I turn this off, I make these zeros, they turn off here. Then we could just end up with all the years that we want. Then also here the statistical analysis changes based on the years that we select. We could then it gives us the statistics on only the analog years that we selected, but also gives us the statistics for all the years. So it gives us two columns, all the years and the just the analog years. So that is the tool. We could, if there is any interest in with the students, I could go in more detail in how it works and everything. But that is that's the tool. It produces a tab for every uh, polygon. The goal would be to have the map with all the polygons, and the goal would be, it would be great to be able to click on the polygon, and then it creates this this section, these three plots, and the statistical analysis. That would be the goal. So I hope there is some interest. Just let me know, and then we go from there. Thanks.